All right, normally when I start these videos, dang it, this light's weird. There we go. Just trying to make it so that I don't have weird shadows on my face. So normally when I start these videos, specifically the SolidWorks and AutoCAD videos, I start by sitting down at my computer, talking you through the process. With SolidWorks, SolidWorks is a unique tool. If you do a lot of pre-planning in SolidWorks and you're ready for the design when you actually start it, you can do things in a very interesting way. And I'll talk about that for a brief little bit, and then I'm going to go sit down on my computer and do SolidWorks. So the idea is we're going to go through design. And the SolidWorks design piece of this is, it's not trivial. In the full design of a component, you're creating lists of parts, you're designing connections, you're applying materials, and this is the full design process of how do we pick which parts we should use, how do we design parts, how do we then prepare those parts for manufacturing, how do we choose what material these parts are going to be made out of, how are we going to do all of this. This is the design process. And so we don't really run into this blindly. We take a very deliberate approach to design because that is ultimately what is best for us as engineers. Rather than just run in and be like, hey, I put stuff together. It's nice. Looks like stuff. Sweet. Instead, we do this with purpose. So in this, how do you go about designing something? Well, as we've talked about in this class, one of the really key pieces is to start with your functional requirements, because if you establish your functional requirements, that really builds everything out. If you satisfy your functional requirements in your design and you satisfy your constraints, then whatever solution you come up with is going to be valid. It has to be. So we do kind of take that approach in design. The first piece that you have to focus on, the most critical piece, is the one that is quintessential to your design process via your functional requirements. So we have a number of different functional requirements that are really important. First of all, it's, it must transport, which means it has to be able to move. Second, it has to be able to carry a passenger. I don't remember any other functional requirements I gave you, but these are kind of the two biggest ones. And there are two different ways that we can approach this. We can start with our very first design piece, so to speak, to be the chassis of our vehicle. For this would be like a bike frame, or it would be like the frame for a motorcycle, or it'd be like the chassis of a vehicle, frame of the vehicle. You can start with that, and then you mount everything to it. That works. That is totally valid. It starts with this functional requirement. What I'm going to do, what I'm going to do for my vehicles, I am actually going to take this idea of build the chassis first. But what some people do is they try to make their system be a lot more attain to this idea that there's going to be a person in the space. And building for a person is a much different experience because you have to take into account ergonomics. You have to make sure that, if you have some kind of handlebars or some kind of steering wheel, it has to be close enough to the individual that they can grasp it, but not far enough away from the individual that, not so close to the person that it's just like poof, right in their chest, which makes it very difficult to get in, get out, and it's not very size inclusive, so to speak. So hold on, I'm going to shut off my phone because it's dying and screaming at me. It's a problem with, I don't really have people who want to talk to me. I just want to have people who talk at me. It's mean. So that's really the two, for this design, that would be the two different areas that we could approach that. Generally speaking, you want to pick some starting point that makes sense to your functional requirements. For me, it's the chassis, because the chassis is ultimately what makes this a vehicle. So I'm going to start there. What I'm going to end up generating is I'm going to come up with one part. I'm going to figure out connections. I might figure them out as I go. The nice thing about SolidWorks is you can go back in and edit things and figure out new ways of connecting things. And if a connection doesn't work, you go back and redesign it. SolidWorks is made for the redesign. It's a very, very powerful tool in the design process. But we are going to be designing connections, and we are going to be ascribing materials. Now, I'm lazy with my material choices. I usually just pick a really low grade of steel because, quite frankly, it's cheap. If we were designing a bike, a low grade of steel probably wouldn't be sufficient. If we were designing a motorcycle, low grade of steel is pretty good. With a bike, with being a human-powered vehicle, it needs to be something that it has to be lightweight as a material, because you're pushing a lot of momentum. Those of you who are in physics right now, you're talking about momentum. Having a large body of mass that you as a person are trying to force forward, it requires a lot more force. And then when you go to a brake, it takes a lot more braking force, and you just lose a lot of energy. So having a really low momentum frame in general is a good idea for any vehicle. Now, a lot of our vehicles in today's world are very heavy, but that's different. That's because in a collision, you want your momentum to be greater than the other guys, because that means you survive more likely. But yeah, different story. So I'm going to go ahead and turn around the camera to my desk. I'm going to get situated, and then we're going to start doing some design drawing. So drop my light, turn it around, drop my camera. Look, you're flying. Probably have to zoom into. Yep. And zoom in. And then I'll just go jump in place. Hopefully none of my cords get destroyed. All right. Okay. I have a mouse. I have several mouses. I have mices. There's a mouse. Grab my mouse and plug it in, because there's no friggin' way I'm going to be doing SolidWorks without a mouse. And then I'll go ahead and switch to my desktop view. Now, first thing I'm going to do is SolidWorks. If you downloaded it correctly, you'll get a bunch of different SolidWorks files. For this class, we're only going to focus on SolidWorks. Now I have a 2018 version. It's just because I'm old and out of date. All of you should have the 2020 to 2021 version. We will not be using SolidWorks Electrical this round. So just go ahead and pop open SolidWorks. SolidWorks is an extremely resource-intensive program. I should have closed my internet browser, because SolidWorks is going to complain the fact that I'm using OBS and I'm trying to use SolidWorks at the same time, and I'm trying to, exist in the world while running SolidWorks. SolidWorks is it's a very resource-intensive program. But that does give it a lot of capabilities, so I'm not too terribly upset by that. And it likes to complain more than really affects you. It does take a while for it to load up. Notice I've been drawing shields and walls because I'm an adult. So what we're going to start with here is we're going to start with a part. Now, as we discussed in our lecture video, SolidWorks really comprises 3 different files: parts, assemblies, and drawings. For the design process, we're going to be focusing primarily on parts and assemblies. Later on in class, we'll talk about drawings and the use of drawings. But for now, parts are it. So I go ahead and click part. It loads the model view, And yeah, there's the background. I can see all three of my planes. If I hover over them, it's my orientation. Here's my axis. I'm gonna start by clicking on sketch, go into a sketch. And what I wanna do is I wanna try to draw my vehicle as if it is standing upright so that the top plane is looking at the top of it, front plane is really looking at the majority of it, right plane is looking at like the front end of it. So I will click on front plane, and then it's just time to draw. Now, here's what I'm going to do. I am going to use a feature in SolidWorks called Swept Boss Base. And what that does is it allows you to create a path, and then from that path, it allows you to then form a shape. In manufacturing, machining, this would be very much akin to taking a tube and bending that tube into a certain shape. And that's kind of the approach I'm going to take as I design this frame. So I'm going to start with, now the design that I'm making, this is probably not the design that you're going to make, but it's the design that I'm going to make. I'm starting with a frame. So to start with a frame, I am going to basically make some tubes that go into a certain shape that defines the frame of my vehicle. Now, for your project, also, you have to keep in mind that as you work on this design process, one of the requirements is that you have to do something innovative. Now, this could be something as much as maybe making a steam-powered vehicle, something that runs off of burning yard waste. That would be innovative. In today's world, we don't really have that type of product, and that's really all it takes to be innovative, is just do something that nobody else is. It doesn't necessarily mean that it has to be technology that nobody's ever thought of before, and it really doesn't even need to be as drastic as using steam power. It could be anything, as long as it is something that is not easily and readily available on the market today. That counts as an innovation. So for my innovation, I'm going to create a bike, but my bike is going to have a little battery assistance in it. Now, there are those types of systems that are available, I'm aware, but I'm also going to make it so that like you could reverse power, so you could like prop your bike up and power small electronics using your bike. Because that is something that would be interesting. You're out on a bike ride and say your phone gets low, you could actually plug in and use some of your bike power. It would be exhausting, but you could. But you could use some of your bike power to charge your phone. Or on the other side of it, say you're out and about, you're biking at night, and you could plug in a little USB light into it and just shine it around. So that's going to be my innovation. It's going to be an electric motor on a bike, which is not really an innovation, but it's unique, at least the way that I described it. And so all of these videos that I'm going to create is based on this idea of an electric motor on a bike, okay? Now, I will say with absolute certainty that you could take this any direction you want. I didn't give you constraints on your system. I didn't define what kind of vehicle you have to create. I didn't define what kind of innovation you have to make for a reason. So if you're absolutely hard up for ideas, you can try to steal my idea. You know, creativity is hard for some people, but I would like it if you did have some creative approach to this project. So that's kind of where I stand here. So I'm going to create a bike mount. Well, that sucks. I created a drawing and then I yep. Okay, there we are. Now, the controls that you can use in SolidWorks to get around is if you hold down Control button on a Windows keyboard, because remember you can only do this on Windows computer. If you hold down Control and drag, that's how you pan. If you just hold down the center mouse wheel by itself without holding down the Control button, then you rotate. Okay? And then you oftentimes get disoriented very quickly. You can click on these axes down here if you want to see different views. Like for example, I'm going to be trying to draw on the front view. So here I click the Z axis. It zooms in on the Z axis. If you click on the Z axis again, it'll switch to the back side of the view. There are also some other view holder ports. I believe there's one over here. I've never been very good at those. I pretty much only ever use the origins for view orientation. It's one thing that I really suck at in SolidWorks, but we'll ignore that. So I'm going to start with just the general shape of what I want my bike to look. Now, I will also say that I am plagued by the fact that I am an engineer. If I go to, let's say I jump on here and I'm like, okay, bike frames, and I just look at a bike frame shape, you'll notice that this is very, this is the fairly standard for a, oh snap, $2,000 bike frame. But this is fairly standard for the shape of a bike. You have your front forks, you have your triangular frame, you have this frame here. For me, who I'm not a competitive cycler, I like mountain bikes because, quite frankly, I have a very sensitive butt, okay? I like to have a little bit of a suspension between my rear wheel and my bike frame. And I'm not seeing any right here, but let me just see if I can just type in mountain bike and get a view of it. Dang, still isn't the kind of... Ooh, electric mountain bike. Nice. This is very similar to what I'm doing, although I want mine to be a little bit more comfortable. I like having a rear spring. Rather than have all of the suspension here, I like having a spring here too. And that's how I'm going to design my bike. But this bike generally takes this shape. The nice thing about this is that this piece here is located such that it allows for seat height adjustment. It allows for people who are a little bit bigger so that their thighs don't rub against the frame, which you don't really want that. But it's also a very strong frame that doesn't tend to fracture. And that is important ultimately. So that's kind of going to be the direction that we go with the design of my frame. So I will start here, which is like up at the handlebars. I'll draw down, and then I'm going to draw up. Okay, and then I'm going to go back because I'm creating just a triangular shape. You notice right here I drew sideways, so this is a horizontal constraint. Both of these points I link directly to the origin. You'll notice this line is now black. That black line means it is partially constrained. Now the other end of that line is this blue dot here. That blue dot, I can move this blue dot sideways, because remember it has to be in a horizontal line. So because I can move that blue dot sideways, this black line is not completely defined, it's just partially defined. And I can take this blue dot here and I can move it anywhere I want to as well. Because none of the angles or lengths or anything really have been defined. If I go back and look at my reference image, it's not quite a triangle, but you know what, it's whatever. I don't care enough to try to make it perfect. What I will say is, because I want this to be manufacturable and because I'm an absolute geek, I'm actually going to make this piece here be one tube. I'm going to delete this top line up here. Oh, no, sorry, oops. What I'm going to do with this top line up here is I'm going to make it for construction. Oh, no, I don't want the whole line to do that. Control Z, escape, Control Z. Gotta make sure that I just double clicked to get out of my sketch. Yes, I will click on this line right here and I will make this to be for construction. okay? Which means that's not a real line, but it's useful there because I can apply this constraint to it to make this horizontal. Now I could easily just pick these 2 points and add a relation to force them to be horizontal to each other. That's another way of doing it, but I like having this here. What I am going to do quickly is I'm going to put a fillet on here. You either have a fillet or a chamfer. Fillets and chamfers work the same way as they did in AutoCAD. So it's not anything big. I'll pick these 2. Right now it says, hey, what size do you want it to be? That fillet is probably going to have a radius of around 4 to 6 inches. So I'm going to type in 6. And you'll notice it says that, oh man, you can't create that fillet. Well, I'm going to have to quit out of this. Problem is, it doesn't know how big my design is going to be. So here I got the handlebar here. I got the seat about right here. Handlebar is going to come up and out. The seat is going to come upward also and out. So I do have a few more components that I need to model. But I want to try to really capture this curve right here. And to do so, I'm going to say, okay, this distance here is about 28 inches, 28 to 36 inches. So I will just define my my line and say that it is a certain dimension. I'm going to say this is 36 inches. Okay. Now, the first dimension you throw into SolidWorks really defines the scale of the rest of your drawing. So here I said 36, you'll notice nothing changed. It assumed I wanted this to be 36 and the other ones are somewhat proportional to that. Now I can go ahead and dimension between this line and this point down here and say, well, that drop, it goes down about 24 inches. Okay? And this point right here between where the front handlebar is and where the bike pedals are, this point and this point, I have the ability to dimension it in line, which would allow me to dimension the length of that line. And I also have the ability to dimension it horizontally, which is the X directional distance, or I can do it vertically, which I've already done that. So I'm going to do the X dimension on here because I don't really care about the length of that line right there. But I do want that distance to be about 24 inches. Okay? Which does give it kind of a backward leading triangle. You'll notice that all of my lines now are black, which means that the whole sketch is fully defined. There isn't a point and there isn't a line on my drawing that is blue because it is fully defined. So I'm going to go ahead and exit sketch. You'll notice sketch 2 shows up over here. I don't have any issues with it. If you did have issues, it would show up as like a stoplight. If you do over constrain it, you will create some issues if you put in too many dimensions or if you put in too many constraints. SolidWorks will say, I can't build it with all of the dimensions and constraints you made because some of them are driving and some of them are driven. So it's just best, in my personal experience, I like using constraints more than I like using dimensions. But that's just because if you use a constraint, you have to go back and redesign it. It's easier for me to adjust the constraint than it is to go back and try to neatly rebuild something with dimensions. And in general, that's the case. When it comes to it, constraints are your best friend in SolidWorks. So I have this, but now that I've had this sketch, I'm going to go on and create another sketch. And this time I'm going to create a sketch and it says, select a plane. I don't have any planes. One thing I can do is if I bring this down, I can actually sketch on the right plane here. So you'll notice I click right plane and now I'm in a sketch. All of a sudden it's called sketch 3, but I'm not in the right plane. If I were to try to draw a line, there's nowhere I can even draw it because I'm drawing on this plane here, which would just show up as a line. So what I need to do is I need to orient myself such that I'm looking at that plane. If I go ahead and hit the X axis, I'm now looking at the right plane. If I draw some lines in here, you'll notice they'll show up now. Okay. And I'm going to delete all of those because I don't need them. But what I'm going to do is I'm actually going to use a circular tube. Why am I using a circular tube? Because they're easier to manufacture. So to create a circular tube, I'm going to create a circle. I'm actually going to make this unnaturally large. for a reason. And the first thing I'm going to dimension is this tube diameter, well, the tube wall thickness, which right now is at 4.6 inches, which is a little bit huge, well, just a little bit. I'm going to change this to 0.125. Okay. Woo! And you'll notice that it scaled down my whole drawing because it said, wow, that's tiny. I'm now going to dimension this outer tube, and my outer tube diameter is actually going to be 1.5 inches. Okay, so you'll see this thing kind of grow now. Now that I have this, both of these were located at the origin. Both of these I have given the diameter of the circle, so it's fully defined. Every line is black. If I hit exit sketch, now if I look at it, I've got this circle profile right here, and I've got this line. I'm actually going to go back in. I forgot to put in an angle in here. I tried putting in a radius here earlier and forgot to finish that. So I'll zoom back in on this drawing, hit Control, drag my mouse wheel to pan, scroll my mouse wheel to zoom in here, and I'm just going to do a fillet. Click it between these two. Now this is currently at 0.1 inches. So that yellow piece there is the preview. I want this to be more like 6 inches. So yeah, that's more like it. So I'll go ahead and hit yes. And now that is my drawing. You'll notice that this comes in and it is already dimensioned with this radius of 6 inches. It's already set to go. All my lines are still black, but now I have this nice curvilinear line that I can use. So go ahead and exit sketch. I will go back to my sketch 3. Actually, you know what? I'm going to sketch, not have anything selected. Go into my features tab. Now that I have two sketches, I have this thing here and I have this line. I'm going to do a swept boss base extrusion across that line. Okay, so for sketch profile, this is what I'm picking right now. Sketch profile is the circle. So I go over here and I zoom in and I click on this right here. Okay, and it picks profile sketch 3. And then I zoom out and it says, okay, what is the path you want it to take? So I click on this, and you'll notice now this is the bike frame that I have created. This is one piece of the bike frame. And this is one solid tube that would just be bent and made into place, and it would have that shape. And that's my bike frame so far. So I'll go ahead and hit yes because I like it. You can change some ways of how the ends are built and that sort of thing. At this point, I don't care enough. I can always go back and adjust those later as needed. But now you'll notice all my drawings over here on the left side in this tree have disappeared because both of them now exist under sweep 1. And I could rename sweep 1 and call this main frame, something like that. I can rename my sketches if I really want to, but this is my main frame component, and everything else is going to be built off of that. So that's fun. I'm going to go ahead and I'm going to do this again. Okay, I want to sketch a circle. I want it to be right here, and it's going to define a bar that goes from here to here. Now that's going to be a weird geometry because if I'm going from here to here, it's a bar that has to be kind of cut. It's a bar that has to look a little unique. The end conditions are going to be a little rounded because they're going to have to wrap around this bar. But I can make SolidWorks automatically generate that component for me. And the nice thing about it is, if I make it automatically generate it for me, that is the type of component that would need to be generated in SolidWorks. So I'm going to show you that feature. This is not a feature that you'll probably use very often, but oh well. What I'm going to start with is I need to create some reference geometry. If I'm going to create a circle right here, I could create it on this plane, which this plane is my right facing plane, but I want it to be over here in the center. So I'm going to create some reference geometry and I'm going to click plane. And what this will allow me to do is it'll allow me to place a plane in a place where I can draw on it. Sometimes it's helpful for establishing symmetry lines when they're not just the standard front, right, top planes. Or in this case, it's helpful for drawing something that's out in space. So my first reference is I need something to build this plane off of. I'm going to go ahead and click this face right here. And what I'm going to do by clicking that face is I'm establishing a plane. You'll notice that there's a plane that's built. It says, okay, fully defined, we're good. If we just make a plane right there, right now it's offset at 0.1 inches, you don't have to have it offset. It won't let me not offset it. Oh well. But it just says, okay, it's 0.1 inches this direction. If I can flip it and go the other way, we're good. I can set this at 0, it'd be right on the plane, we're good, we're done. That's all you need. You pick in order to define a plane, you define it based on another plane that it's parallel to. But I'm gonna make this go the other direction. And that's really all I need to do. So here I'm just gonna have it go back 6 inches in that direction, okay? So now you'll notice I can draw on that plane. This is fully defined, so I can just go ahead and hit yes. We're done. Go into my sketch, and then I can sketch on that plane. I already had that plane selected. I click sketch. I am now currently sketching on that plane. Now I'm going to draw the same profile as I did right here. I'll use the same origin. You can even draw lines projected on here because I'm looking down the x-axis onto this. Everything is a projection, and SolidWorks sees that and actually allows me to pick these points really nicely. And you can add relations. I'm going to go ahead and add a relation between, well, no, I'm not going to. I'm just going to dimension it because I don't want to do that. It's 1.5 inch, done. And then this wall thickness, 1.25 inches. Oop. Distance was a little off. You'll notice it's fully defined. I go ahead and hit exit sketch. And now when I zoom over here, I just have an identical profile there. And then what I'll do is I'm going to do an extruded boss base. Extruded boss base just goes straight out and straight forward. Now in direction 1, I actually wanted to go up to surface, and I'm going to pick this surface. And you'll notice it actually creates a very complex geometry that matches this circle to that surface. And I hit, if it hits merge results, what it means is this becomes one part. If I don't hit merge results, this stays as two separate parts, which that can be helpful if you want to know how to build this piece right here. I'm going to go ahead and hit merge results because I don't want to go into that complex. Now, I'm going to have this go in a direction 2, which just means that it's extruding in one way and then it's extruding in the other way. Okay, in direction 2, I'm also going to have this go up to surface, and then I will zoom out and I'll click this surface. Let's see if it'll let me see what it looks like. Oh, nope. Up to surface. Pick this one. And I'll hit yes. Oh, and it says it cannot terminate the extruded feature. It's probably because this. Yeah, oops. I won't be able to make it go up to surface. At least not the way it is. So for right now, I'm actually just going to set this as blind and hit yes. Well, don't do that. Yeah, okay, there it is. I just had to switch the directions of what direction 1 and direction 2 is. Hit yes. Now the issue that I'm having here is this side meshes nicely, but over here I actually don't have a face right there. So there is one thing that I can do. I do want this to go up a little bit, but I actually kind of want it to flare out because I want to have a platform for my seat. So I'm going to go back into my mainframe, and all I'm going to do is I'm going to adjust my sweep. I'll right click on my sketch. I'll go up to edit sketch, orient my axes nicely. I'm going to take this line and I'm going to draw this line up here like this, and then over here like this. Okay, and what this will be is this will be the platform on which I build my seat. And then I'll probably just have it where you can lift and lower off of the seat platform, but that's how I'm making my bike. Deal with it. Where's my shades? Bam. So what I'll do is I'll set a height for this, and I'll add some relations, because I said I like having relations better than dimensions. I'm gonna click on these two lines. You'll notice that only two lines show up. If you have a point in there, you can click on it, hit the delete button, make it go away. If you accidentally have like 3 lines, you can delete all of them that way. But I'm gonna go ahead and add, oop, that was one of the lines I had selected. Add these 2 lines, they turn a light blue color. There is no current existing relations between them, but I'm gonna make them collinear. When I make them collinear, it means that this has to be at the same angle. They have to be in line with each other. And I'll go ahead and hit yes, I want that relation to exist. Okay. So you'll notice this line itself turns black. This point here is blue. It's because I can still, whoa, what are you doing? Decided to go on a vacation. Because I can still move that point. So it's not fully defined yet, but at least I have the angle of that line. I'm going to go ahead and pick these 2 lines here, and I'm going to say I want this to be 8 inches. Okay, so 8 inches. Done. Awesome. I'll click Add a Smart Dimension. This is fully defined as it is, but I want a curved radius here, because remember, this is something that I want to project. I want a curved radius here. So I'm going to go ahead, click these 2, hit yes, gives me a yellow line showing that it knows what it is. This is at a radius of 6 inches, so it's fairly big. And this is now going to be my design. I'm going to have my bike front come up here like this. I'm going to have this be down here like that. And if I do make some adjustments to this design later, my relations that I set up are nice enough that it's going to kind of be able to adjust around it. So I'm going to go ahead and exit sketch, and you'll notice you get a little blue twirly wheel, and then the whole profile changed. This is now my new bike frame. That's all I had to do was just adjust a few lines, draw a few lines in, and now it's bigger. I'll go back into my Boss Extrude, and I'm going to go up to Edit Feature, and I don't want this to be blind. I want this to be up to surface. Okay? And if I pick a surface, it's going to be this one. Okay? And if I, yes, rebuild error. Don't do this to me. I need to pick both of these faces. I don't know what's going on. It does not like it that I am doing this right now. So you can try things like up to next, see if that works. And then up to next here, see if that works. Let's try it. Nope, rebuild error. It doesn't like that. Oh well, I'll just keep this as whoop, up to surface, have that one be up to surface. And then I'll just blind project, because you know what, it's not going to be perfect, but we'll say maybe 24 inches. See what that looks like. Looks like it goes all the way to about right there. So let's go to 30. Okay, I'll reorient my axis. It goes over there. If I hit yes, oop, forgot to pick a face there. There we go. And hit yes. And this is my new design. Now, the reason why I didn't like that was because, yep, it's because I have two different lines there. I'd have to go in there and actually change that in order to make that work. Which I guess I should show you how to do it. So I couldn't get that to work. The reason why I couldn't get it to work is because my sketch 3, my sketch 2, if I go in here, the issue is that these are two different lines. With this horizontal correlation right here, really what I need it to be is I need this line to extend from here to here. I need them to not be different parts. But I'd have to change everything to do that. I don't want to. So at this point, that would just have to be some weird feature that somebody would have to do some weird cuts on to make it work. And then do some ugly welding. And probably have to make some intern somewhere model that for me. But this is now my bike frame. I can add a front piece on the handlebars. I can add further additional build out for my seat. I can add some components in here. But this is ultimately what I'm going to be building my bike on. This is my main structure. What we're going to be doing, I'll post another video probably this week, continuing to build on this. I'm going to try to post videos when I can, just showing the process of how I'm going to go through actually designing this, mounting pieces on this, how to identify and create connections, how to do good build qualities on this. But for now, we got one frame piece. The frame piece looks the way I want it to. I could mount pieces on here if I wanted to. I'm happy with it. But as we've seen, we can also go back in and adjust it. So get your frame. That's my first suggestion. And I'll post another video soon with further discussions on SolidWorks design.